everyone. I welcome you all once again. I am Chetan from the Department of Mechanical Engineering, AVES Engineering College. I welcome you all. So this lecture is basically in continuation with the previous lecture based on the same topic. Previously, we were discussing a problem based on static equilibrium of inextensible string system. So we are going to take one more problem on the same topic. So let's come to the question directly. So students, this is the second problem based on the same topic, a system of inextensible string system. So two extremities A and D. This end is A and this end is D of a light inextensible string ABCD. A, B, C, D are tied to 2 points in the same horizontal line. So these are the 2 points B and C. Weights W and 3W are tied to the string at the points B and C respectively. So at junction B, the weight which is being hanged is W and the weight at the junction C is 3W. If AB and CD are inclined to the verticals at an angle of 60 degrees and 30 degrees respectively, as we can see, this string segment AB is inclined with an angle of 60 degrees with vertical. So by the geometrical properties, this angle also becomes 30 degrees at the junction B. And the inclination of this string segment CD with vertical has been given as 30 degrees. So by geometrical properties, this angle at the junction C also becomes 30 degrees. Show that BC is horizontal. We are going to prove that this intermediate string segment BC is horizontal. Okay, we are going to prove it. And we are also going to calculate the individual forces which are being transferred in these string segments AB, BC, and CD. Okay, so these are the 4 objectives in this question. We are going to find the values of the forces in AB, BC, and CD, as well as we are going to prove that this central segment BC is horizontal. So once again, we are going to use Lami's theorem for the for further processing. First of all, we are going to consider this junction B. We are going to draw a free body diagram of this junction B. So let's start. Suppose this is the junction B, and this force is T1. This force is T1 at an angle of 60 degrees with vertical. And this force is T2, which is being transferred into the central string segment BC. So this force is T2, and the vertically downward force W. These are the 3 forces which are acting on this junction B. So before applying Lami's theorem, we need to calculate the individual forces, or you can say intermediate angles between any 2 adjacent forces. So let's calculate these forces first. Suppose this angle is theta. Because we do not know whether this central segment BC is horizontal or not, we are going to consider that this is having some inclination. Okay, this is not perfectly horizontal. This is having some inclination, and this inclination with vertical is theta. At the end, we are going to prove this, that this angle is theta is 90 degrees. Okay, so this is our main objective. So initially we are considering that this angle is theta. Now, what is the value of this angle? The angle between T1 and W. Clearly, this vertical line is indicating the angle of 180 degrees. So this remaining angle, the angle between T1 and W, this angle becomes 180 minus 60. That is 120 degrees. Now, what is the value of this angle? This complete angle. The angle between T1 and T2. As we have considered that this angle T2 and W, the angle between T2 and W is theta. So this remaining angle becomes 180 minus theta. Okay, 180 minus theta. This remaining angle. So the total angle between T1 and T2, this becomes 180 minus theta plus 60 degrees, which is equal to 240 minus theta degrees. Because this angle is 180 minus theta plus 60. So the total angle becomes 240 minus theta. So let's apply Lami's theorem for this force system. We can very easily write the expression of Lami's theorem here. So T1 upon sine theta is equal to T2 upon sine 120 degrees is equal to W upon sine 240 minus theta. So suppose this is the expression number 1. We are going to use it later. So this is the expression number 1. Now, as we have considered this junction B first, now we will consider the second junction C, and we will draw the free body diagram of this junction C. So let us draw the free body diagram of this junction C. Suppose this is the junction C. This is the force which is acting in this direction CD, and the value is T3. The force which is acting vertically downward, this is 3W. And the force in the direction of B, from point C in the direction of B, is T2. Now, since this angle is theta, by the properties of parallel line, this angle also becomes theta. So let's show it that this angle becomes theta. This angle is 30 degrees. We have already discussed this. Now, let's mark the intermediate angles between any two adjacent forces. So clearly, this angle, the angle between T3 and 3W, this angle becomes 180 minus 30, that is 150 degrees. Okay, so the angle between T2 and T3 is equal to theta plus 30. That is, this total angle becomes theta plus 30 degrees. And what is the angle between T2 and 3W? This angle is clearly 180 minus theta, because this angle is theta, therefore the remaining angle becomes 180 minus theta. Now we can apply Lami's theorem. So T2 upon sine 150 degrees is equal to T3 upon sine 180 degree minus theta is equal to 3W on sine 30 plus theta. So this is the statement as per Lami's theorem. T2 upon sine 150 is equal to T3 upon sine 180 minus theta is equal to 3W upon sine 30 plus theta. So let's mark it as expression number 2. Now we can compare the values of T2 from these two expressions 1 and 2. From expression number 1, we can calculate T2. Okay, so from this expression number 1, we can calculate the value of T2 as W sine 120 upon sine 240 minus theta. So this is the value of T2 from these two expressions. T2 upon this is equal to W upon this. And from the second expression, we can also calculate once again the value of T2 is equal to 3W sine 150 upon sine 30 plus theta. So both of these values are representing T2. So let's equate the values of T2. So W upon sine 120, W upon sine 120. So it's W sine 120, sorry, upon sine 240 minus theta is equal to 3W sine 150 upon sine 30 plus theta. So we can also write this expression like this: W sine 120. Sine 120 can be written as sine 180 minus theta, and sine 180 minus theta is sine theta. That is sine 60 degrees upon sine. Now look at this, sine 240 minus theta. This can be written as sine 180 plus 60 minus theta. Okay, sine 240 minus theta means sine 180 plus 60 minus theta. And what is sine 180 plus theta? Sine 180 plus theta is minus sine theta. So we can write this value like this: minus sine 60 minus theta is equal to 3W. Now what is sine 150? Sine 150 can be written as sine 180 minus 30 degrees. And sine 180 minus 30 is equal to sine 30. So we can write sine 30 upon sine 30 plus theta. Let's cross multiply this. So we are getting W into, what is the value of sine 60 degrees? Sine 60 degrees is under root 3 upon 2 into sine 30 plus theta is equal to 3W into, what is the value of sine 30? Sine 30 is 1 upon 2 into, with minus sine 60 minus theta. Now we can open these expressions using the formula sine A plus B. Sine A plus B is sine A cos B plus cos A sine B. And we can also elaborate this expression, or we can also write this expression like sine A minus B, and sine A minus B is sine A cos B minus cos A sine B. By further simplifying this expression, we are coming to this conclusion directly, that 2 cos theta is equal to 0 degrees. We can find out this result by putting the values of sine A plus B and sine A minus B as per their standard formulas. And further simplifying, we are going to get this final result that 2 cos theta is equal to 0 degrees, or we can conclude that theta is equal to 90 degrees. So clearly, it is indicating that BC is horizontal. Because we have assumed that this angle is theta, and we have proved that theta is 90 degrees. Therefore, BC is horizontal. BC string is horizontal. So this is the first part. which we have proved now. Now we need to calculate the values of the forces in AB, BC, and CD. So we can calculate very easily using the formulas. Let us see what is the value of T1. T1 is equal to W sine theta upon sine 240 minus theta. T1 is equal to W sine theta upon sine 240 minus theta. Sine 90 upon sine 240 minus 90. So value of T1 is equal to 240 minus 90, that is 150 degrees, and it W sine 90 upon sine 150 degrees, and it is coming to be W upon 1 upon 2, that is 2W. This is our first answer. Value of T2. How to calculate the value of T2? Let us see. This is the value of T2. We can use this formula. 3W sine 150. 3W sine 150 upon sine 30 plus 90. 30 plus theta means 30 plus 90. So this value is coming to be under root 3W. And the value of T3, how to calculate value of T3? T3 can be calculated using this expression. T3 upon sine 180 minus theta is equal to 3W upon sine 30 plus theta. From this, T3 can be written as 3W sine 180 minus theta, 3W sine 180 minus 90 upon sine 30 plus 90. By calculation, the value of T3 is coming to be 2 under root 3W. So that is the third answer. So in this way, we have proved that this central BC string segment is horizontal because theta has been found to be 90 degrees, and using this value of theta, we have calculated the values of T1, T2, and T3. So all the results have been found. So in this way, this problem has been solved. Okay, thank you so much.